Hello students, myself Dr. B. Sridhar, Professor ECE, MLR Institute of Technology, Hyderabad. Now we are going to discuss about bending losses in optical fibers. Generally, signal degradation occurs due to absorption losses, scattering losses and radiative losses. So, absorption losses due to some atomic defects in the core cladding material, and scattering losses due to microscopic variation in the material density, and radiative losses is nothing but some power loss. Now, this bending loss comes under the radiative losses. Now, what is bending loss? It is one of the important loss in the optical fiber communication. Now we are going to see about now bending losses and micro and macro bending losses. We will see first what is bending loss. Here the loss induced by the physical stress on the fiber, then automatically the core cladding structure may disturb. Once the core cladding structure is affected, so the light propagating path may be disturbed. Once the path is disturbed, automatically what will happen? The light automatically it can enter into the cladding area. You can call it as a escaped ray. It's an escaped ray. So if it is escaped ray, in a sense, what will happen? Generally, here we may lose some power. So here you can say this is the initial power, so this is the final power. So finally we have to calculate, so whatever the initial power we are sending, we have to get the same as the same proportionality of the final power. But so because of this bending, the bending nature of the fiber, so the loss may be getting more. So in the form of escape ray, you can call the name called the escaped ray. The escape ray occurs depends upon the bending. So here the main definition, the losses which exist and optical fiber undergoes some bending is called a bending loss. We will see the types of bending losses. Here the bending losses can be categorized into two. The one is micro bending losses and macro bending losses. So we will see one by one. Fine. Let us see micro bending losses. So we know that the bending losses is nothing but some physical stress on the fiber. So the light path may be disturbed. So it becomes the ray may be escaped out from the propagating path. Okay. The same is bending loss. Now coming to the micro, in the sense, so the micro loss due to a small bending of the fiber. See, either the bending, it may be either the core or cladding, the slight bend at its surface. The bending nature at the core and cladding at its surface. So automatically the loss may be introduced. Here if you see this arrow mark here, see, this is nothing but the escaped ray. So this is the actual input, the light can be propagating in the proper path. So finally what happens? So see here, this bending, so automatically the path may be disturbed. This path may be disturbed. So here we are getting the escaped ray at this end. Okay. So generally this bending occurs due to some stress on the fiber. Sometimes micro bending losses occurs due to some manufacturing defects in the core also. So while manufacturing of the fiber, so due to some defects or manufacturing defects, some small bend may happen, it may introduce. So that bend also leads a power loss. So not only in the physical stress, also this bending losses occurs due to the manufactured defects. Fine. So because of this bending, it affects more on the multimode fiber. So we know very well the multimode fiber here, the multiple signals are propagating in a single fiber core. Okay, if bending is occurred in the fiber core area, so the loss may be occur more. So that's why I mentioned. So if bending occurs in the multimode fiber, here you can get more attenuation, you can get more power loss, more radiated losses. So the micro bending plays a very important role while designing or while seeing the optical fiber communication system. So we can see absorption losses, scattering losses, bending losses, core cladding losses, all the losses we should concentrate to achieve the effective communication system. Fine. Now we come to the macro bending. The macro bending, so this bending losses caused due to the large scale bending of the fiber. So actually, so this is a fiber core. Okay, so this is the center point, this is nothing but the radius r. So what will happen? Some large scale of bending, generally it occurs due to the cause of installation. While in installation, so it may undergo some bending. Okay, so sometimes this may be eliminated. So when the bend are straightened, suppose if you take this fiber, so here, so if you straighten the fiber, so maybe the escape ray may be minimized. Anyway, it's loss only. It is loss only. Fine. Not only that, so the large scale bending of the fiber, so which is exceeds the fiber bend radius, then automatically the light propagating path may disturb and the light can leave the core and it will travel into the cladding. Otherwise, it is called as the radius losses because it deals with radius. So we can call it a radius losses. So now how to avoid this one? So maintain the proper bend radius, so we can prevent the damage as well as signal loss in the optical fiber. Not only that, so here we are having the jacket. So if you use this jacket or the fiber to strengthen the fiber, then the stress may be, suppose if any object falls on the fiber, so what will happen? The fiber stress may be reduced. Suppose here the fiber is there. Okay, so here some jacket we can present, encapsulated jackets. Okay, so if you stress is applied onto the fiber, then it can minimize the bending effect, bending loss. Okay, generally to reduce the macro bending loss, so we can maintain a proper radius. So for micro bending, so we can use some jacket over the fiber, so to reduce the micro bending losses. So this is one of the important losses because we have to concentrate more on, because the main thing in the fiber communication, scattering and material due to the atomic defects or due to the material density, but in bending loss 90% based on the stress. So here you can easily rectify, but here if not, the power loss is more in the bending losses. Thank you.